Okay, it's recording. Sorry, there was a problem with the computer. Let's start sharing. Which one? We should not using this one. Okay. Okay. Let me see why we're having a problem. Yes, okay, here we're going to talk about why we should rack mount solar energy storage and AC delivery systems and standardized connectors instead of point-to-point wiring. Okay, we need to firstly clarify what we mean by point connections. Here I mean connections that are made using wires that are connected one by one using connector locks or terminals. These are common because it negates a connector housing and has a more direct electrical connection to the circuit and are usually cheaper and faster for the first install and are usually easy to connect. But when expanding, repairing, or exchanging equipment that's connected together, okay, yes, using more than one wire, removing and installing them would be time consuming, usually requiring screws and also they're not always mechanically attached to the host system securely. Besides, the copper of the wires is neither waterproof or very strong, so it's a good idea to try to migrate to connectors with a back shell. Hence why we're trying to use a different type of connection method. So now we need to see why standardizing the solar power delivery from the roof panels to the MPPT solar charge controllers would be best done using these sub connectors. Sorry, which I'm proposing here. In the connector world, almost all rugged connectors that have a suitable back shell are almost always circular or rectangular. Firstly, strong standardized circular connectors are almost always military/aerospace quality, and therefore they're more expensive and not always the best in space savings because they're round, not like square and stuff. Because they because these connectors because these circle designs of the connectors, the circle design of the connectors usually geared towards fast removal for maintenance. As you can, well, maintenance. But strictly speaking, this is not necessary because in the solar industry, if the connector is rugged enough, it won't break that often. So we don't. So we don't. So when the next best thing, so we don't need to side change it more often. And so the next best thing is a rectangular connector. Yeah, rectangular connector. Standardized over the years with a action and possibility of being locked to the system, and that only goes in the connector one way. The connector series is a D-sub. That's why we chose it. Now here we show the connector chosen for the solar connection. The specifications we chose was based on normal withstanding voltage of the solar panel connectors and their maximum ampacity, which is how much current they can normally take, which is 600 volts and 25 amps, which is around 15 kilowatts per input. Now we can use another illustrated connector configuration to connect the solar charge controller and inverter. There's up together using 240 volt cabling, a maximum of 100 amps, total 500 amps per contact, so they can effectively sync or source power from the solar panels, batteries, and the grid to efficiently manage the house grid or house, sorry, the grid. If you put these in a rack mount system, um, close to solar farms, you could also use this, but at much larger scale than what we use at a home or at a facility, a solar facility, um, or building. So that we're building. So well, that's why my proposal for rack mounting is really makes sense, because this is why it is easy to expand. This is way why it's easy to expand later on and add any other electrical system uh, in the future. And this makes the installation much more earthquake. Sorry about the little bit earthquake proof. Now I propose we standardize the control and communications between these systems as a fiber optic connector running on LC full duplex using Ethernet standard protocol, which I forgot apparently to put here. This way, we increase the reliability of the communications link, because now lightning or any electrical noise can jeopardize the connection. Um, and so it's better to use fiber optics for that. Also, that the so basically using standard protocols on the Ethernet connection on the fiber optics. So, uh, thank you for listening to my presentation and basically following me through the problems I have in my computer. So this is the connector we chose for connecting to the solar panels. And here we can see a bunch of different connectors. Sorry, this is a different place. Basically, this is what we chose to over here to connect to the solar panels from the roof to the house wiring for the solar panels, which then basically splits this connection into two of these connections. And then what we could also do is use something like this connection, which has four DC connections. All the communications are fiber optic. Something like this, which has like five connections. Sorry, four for carrying AC, two on each line, and one for carrying ground for ground protection, complete ground protection. This would be a perfect standard connector to connect all the systems AC wise under 240 volts, maximum 100 amps, 50 per these contacts. And so the communication would be also handled with fiber optics. Any other connector that any system uses, if it's like low signaling rates, you can use any of these, and that's what makes this whole system really great. Thank you for being here with me. Can you stop sharing?